Hello and welcome to another edition of the Data Center Pulse Chill-Off segment. Today I've got with me Brian Day. He's a member of Data Center Pulse and he is actually operating the project itself, the program manager. Welcome, Brian.
Thanks.
So we want to give a quick update to the people that are interested in this. You want to give us an idea of who actually is confirmed to be participants?
Sure. So as Dean had mentioned in the previous update with Chill-Off 1, we're basically taking that to the next level. And so we've got a larger set of participants this time. Really excited to include Kunur, their Cooltherm and Coolloop products. We've got IBM and Rittal with their rear door heat exchanger products. APC is going a little bit beyond what they did last time with not only the hot aisle containment solution, but also their rack containment solution.
Okay.
We're going to be testing the new Liebert XD system, which is intelligently controlled now in terms of the fan speeds and that kind of a thing. So we're really excited to see the results of that.
And it's including XDH as well, right?
Cool.
Which we were doing XDV last time for the high density.
Correct.
So now we're doing XDH too.
Yeah,
Okay.
yeah, good point. Then we also have some products from Sun in the test this time. Sun's Black Box, or the Modular Data Center as it's officially known, and then the Glacier product from Sun 2, which is a rear door heat exchanger refrigerant controlled. We'll have that in the test, and that's about it. So,
Great.
and then sorry, I forgot one. Clustered systems. So
Right, so the cold plate technology.
right down to the rack. So we're very interested to see how those stack up. Much larger set than last time,
Right.
and not only that, we'll be pushing the per rack densities way beyond what we did last time as well. So we're really interested in seeing how that stacks up across all of those.
Now, this is a lot of vendors, and I mean you're the guy that's in charge
Right.
of what's happening now, schedule-wise. What does it look like? So you've got
Right.
8 or 9 vendor?
11.
Pardon me.
Sorry,
Okay.
8 vendors, about 11 tests.
11 products that are going to
Right.
be tested within it.
Right.
Okay, and then within that now we're going to be running the different types of tests. So why don't you tell us about the schedule and the tests?
Right, so right now we're heavily focused through the month of February and get everything set up. So
Okay.
we're going to start with the simplest tests first, which are single rack configs, then move into dual rack configurations, and then all the way up to the big 8 rack configuration tests
Okay.
later on in the schedule. But February is going to be a very busy month. It is a very busy month. Our kickoff of official testing is March 2nd, Monday, March 2nd. That's what we're shooting for.
Keep the fingers crossed.
Right,
yes.
right. So that involves everything. We're getting the test environment set up, all the electrical, mechanical network, all that. So we can literally hook up the first system, kick off testing officially on March 2nd. The bulk or the entire testing will be done from March through the end of June. That's
Okay.
our window. So 4 months. Sounds like a lot of time, but for that many tests, it's going to be really tight.
Well, then let's talk about the tests. So who
Right.
are you kicking off with first, actually?
Our current target is to kick off with Kunur's Coolloop product, which is a single rack configuration.
Okay.
We'll test that at the 16 kilowatts per rack loads, and then the 30 kilowatt scenario as well.
Got it.
And test-wise, what we're going to be doing for all the vendors is we're going to be comparing not only kilowatt per ton versus the kilowatts per rack, but then we're also going to take that to the various redundancy levels. And then we're going to start varying server inlet air temperature and then also varying chilled water supply temperature as well. So there's a lot of tests that need to be run for
Right.
every single vendor. And then unfortunately, just due to the size and complexity of these tests and the type of test environment that we have, we need to run most of them sequentially. So hence a lot of time.
Right. So when you're talking about, you're going to have a chart that is kilowatt per ton
Right.
and density. Then we've got kilowatt per ton with chilled water variances,
Correct.
right?
Correct.
But that is staying the same.
Yep.
Okay. It's just now we're changing the parameters of the test itself and see how they plot
Exactly.
across there. Okay. All right. And then the other thing, and Brian and I just got out of a great meeting about the workload simulation. And we wanted to share this with everybody because what do we run on top of this
Right.
that would simulate a real environment?
Right.
So we're going to give you an idea here. So take the coordinates like this, and we still have kilowatt per ton
Correct.
on this side. Then this is really time. And within this, so we've got eBay, which is going to be simulating their auction trends throughout there. So the actual loads from Europe and Asia and the US and where they fall. And then on top of that, we have a major bank that's actually going to be putting in high performance computing. So they take all of these trading activities that happen during the day, and then there's like a 1 hour chunk where it just spikes through the roof. And so if you look at it, here's where we would have, based on these quadrants of time, we have this cyclical type of activity, but at the same time you'd have Europe dropping off and then starting to ramp back up. And this is from the auction standpoint. Then you look at, from the high performance computing standpoint, they have these things where the trading floor is going, and then all of a sudden, whoop, they have this spike worth of actual consumption of that actual high performance configuration to evaluate what those trends were, what the actual trading was. So huge amounts of compute at that point. Then we were thinking about, now let's put in some other just standard loads, right? So spec web or spec power, and that's what you used last year was spec power,
Spec
right?
power, right.
Okay. And Brian ran all of the coordination last year, and he still has all of his hair, so that's pretty impressive. So here we would say perhaps we put spec power that goes in, does a couple spikes in different spots, and just really mixing it up.
Right.
So we want to really simulate what's going on in a real data center. And if you think about it, this kind of looks like a hosting model. You've got multiple vendors actually inside of a center that are running different types of workload. And then you start playing and mucking with the actual types of cooling, the temperatures, and everything else.
Right. Right, exactly. Last time we ran a much more straightforward test of just increasing set points to achieve a certain rack density load. And it was interesting data, but like Dean mentioned, this time we really want to simulate what a true data center goes throughout a typical day, and how the cooling systems respond or perhaps don't respond. That's what we're really interested in, and how those stack up. We want this test to be as realistic as possible and give as much meaningful data as possible.
And this will allow us to say, you get an idea of how the actual workload is going to be generated in there and that variance. But then we're going to go back and do a scatter plot. So Lawrence Berkeley's already got it. Jeffrey, who's writing all the tests and doing this, has got an idea that we take now the load, right, the kilowatt per rack, and you start to normalize this across there to say, well, when I ran these simulations, how did it actually function in there? When I increased that chilled water supply, what happened in the efficiencies across there, right? And my cost of a kilowatt per ton. So overall, I think it's going to come together pretty nicely. You've got a lot of work ahead of you in the next 7 months.
Yep.
But the goal is to really finish this up by June and then start all of the actual reporting and rolling out of this data for the event that's going to come up in September.
Correct.
So, great. Well, thanks, Brian. I appreciate you joining me here on this show. And stay tuned for updates on the next Data Center Pulse Chill Out Focus.
Bring the beat back. Pump the beat now.